Good evening, everyone, and welcome to the National Atomic Testing Museum's Virtual Distinguished Lecture Series. We are joined by Dr. Brent Park, the Deputy Administrator for Defense, Nuclear Nonproliferation for the U.S. Department of Energy's National Nuclear Security Administration. Thank you all so much for being here tonight. On behalf of all of the staff, our Board of Trustees, the Foundation, just want to thank you for taking time out of your evening to be here and to listen to this great presentation by Dr. Park. We are going to ask that everybody save their questions until we open up that for Dr. Park. So just wanted to give everybody a heads up on that. Just allow us to be able to catch all of your questions if we all hold off on those. First, I want to welcome Dr. Brent Park. Now, like I said, we are pleased to welcome the Deputy Administrator for Defense, Nuclear Nonproliferation. He's joining us from Washington, D.C., and is one of our first Distinguished Lecture Series participants. Dr. Park has over 30 years of experience at the Department of Energy. He began his career at Los Alamos National Laboratory, where he managed and contributed to basic and applied research programs in the areas of defense, nuclear nonproliferation, nuclear emergency search team activities, modeling and analysis for nuclear weapons engineering efforts in support of stockpile stewardship, nuclear weapons physics, and basic physics research. Dr. Park served at the Nevada test site as director of DOE NNSA's Remote Sensing Laboratory, where he led efforts to advance and field cutting-edge diagnostics and communications instruments in support of counterterrorism and radiological incident response for the nation. Then he served as associate laboratory director at Oak Ridge National Laboratory, leading the science to application efforts for the laboratory's national security programs. Currently, Dr. Park serves as the National Nuclear Security Administration's Deputy Administrator for Defense, Nuclear Nonproliferation. Dr. Park was confirmed by the United States Senate on March 22nd, 2018, in his current role. He leads and coordinates NNSA efforts to prevent nuclear weapon proliferation and reduce the threat of nuclear and radiological terrorism throughout the world. Ladies and gentlemen, I present to you Dr. Brent Park.
Thank you so much for that kind introduction. It's interesting that I give you this short, more of a personal journey story over Zoom. And who would have thought 6 months ago that we would be doing this? In fact, I need to thank John Longenecker for actually working with me. In fact, this presentation or the talk has been scheduled for quite some time. It has been postponed because of the condition that we're experiencing. But yeah, I really need to thank John for actually helping to set up this interesting over the video presentation. And I just want to say thank you to a whole lot of people who are actually making National Atomic Testing Museum work. Obviously, I saw it go up. And my friend and colleague and a mentor, Mr. Troy Wade, actually showed me from the ground level as it was built. I very much appreciate it. And I think in the audience somewhere, there's a Chuck Costa and many, many others. And so I appreciate everybody who has been staying with the museum all these years, from the design and the building and operational side of it. And also, I need to thank my friends from Nevada National Security Site. The president is Mark Martinez. He's a great friend of mine, and he's been doing an awesome job managing many important missions at, I still call it test site, by the way. And I'm one of those retirees from Nevada test site some years ago before I moved to Oak Ridge National Lab. And also I learned, like many of you, the passing of Nelson Cochran, and it's a sad news for us. Anyway, I get to recognize his leadership over the years in this forum. And I know you share with me the true appreciation we all share for his outstanding leadership. So again, I'm not sure if Nevada Field Office anybody is on, but outstanding leadership by Dave Bowman and many of the people from the federal workforce, and appreciate that. But before I get going, I just want to say thank you to all the people who are working at Nevada National Security Site, or have retired from it, or have been part of the family working with us over all these years. And I really do appreciate and recognize Las Vegas and the great state of Nevada for its contribution to our national security program. So I just want to say thank you to all of you on behalf of DOE leadership and NNSA leadership. And so I just want to say that outright. And that's actually an interesting slide, because that's actually an outline of what I'm going to talk about today. I don't have a prepared speech, by the way. I rarely read from the written speech. So I just want to talk to you as to how my experience might be interesting to some of you as we celebrate many years at the Nevada location for what we call nuclear deterrence mission. I actually saw John Ullman's name while I was briefly browsing through. John Ullman was actually one of my original sponsors at Los Alamos National Lab when I showed up in the late 80s to do my PhD work. It was great. It is great to see John, his name on the attendee list. But that's pretty interesting. But I'd like to actually start from here and now, rather than starting from more than 30 years ago. As you heard, I was studied about a little less than 2.5 years ago. What a ride. What an interesting place the federal system is for a physicist like me. I would not trade it for anything, by the way. This is a really great experience. What a way to make a contribution to national security. It's a great day every day to do public service. And I think my experience from the labs and test site especially have given me tools, experience, and a bit of expertise, and mostly in the form of working with others rather than my own. But again, I just want to recognize a great team of people at NNSA and overall DOE. I never thought a federal workforce was this good. I only saw them from distance for so many years. But again, now that I have spent the day in, day out with the outstanding workforce, I am just blown away every day. I'm learning there's something new every day. I focus more on the policy side, which I'll go into a little bit more. But again, I think that my 30 years of lab site experience helped me quite a bit. And I can actually go over some of the pictures as I go along. But again, I just thought I would give you a little bit of the background as to what I'm responsible for, and hoping to find the connection between what I've been doing to the Nevada National Security Site and the museum itself. So part of my job is to make sure we provide a robust nuclear deterrence, not only for the United States, but for our allies and our interests throughout the world. And obviously, most of you should know about our weapons program that is managed by Dr. Charles Verdon, and also from Livermore National Lab originally. And so I'm not going to touch upon his program too much today. But again, I am managing the other half, which is a nuclear nonproliferation. It's more like a left-right punch, 1-2 punch, big stick, but talk softly, and engage with the international partners, knowing that we're in this together, international community. And that's actually part of what I like to focus on a little bit. It's probably a good idea for me to give you a little background as to what my organization does. So I think most of you do know that with the roughly $2 billion, we actually work with the 12 labs, a site and plant, and they do the core mission on the nonproliferation side. We work with more than NNSA lab sites and plants. And there are science labs like Oak Ridge National Lab, where I retired from before coming to federal system. And also PNNL, one of the greatest laboratory that we have on the science side. And actually they do more nonproliferation work than any other labs within the DOE system. And they've been a true and great partner In fact, Dr. Bill Mady, I'm not sure if he's on this, but he actually made it happen. His outstanding leadership throughout the years made PNNL what it is today. He actually built the lab ground up. It became the national lab under his leadership. So there are many outstanding the contributions from what we call MNO partners, lab sites and plants, and literally within NNSA. I think Administrator Gordon Hagerty always talks about this, how proud she is of more than 50,000 workforce between the MNO partners and the federal workforce. So we are growing every day to meet the challenges head on. And I'd like to give you a little flavor for what we do. I'm responsible for largely 4 programs. And if you will find out quickly that we focus on materials, diagnostics, and then we do quite a bit of policy-related work. But again, that's where the Nevada National Security Site and this Atomic Testing Museum would come into play as well. Substantial part of what we have today have been validated at the Nevada location over the years. In fact, a substantial part of what we do require field validations. And I'm not sure if I would have time to go over today, but we actually operate several critical test facilities, what we call test beds, at the Nevada National Security Site under Martinez's leadership, working with Dave Bowman and everybody else. And it's critical for us to validate what we need to observe and verify for 3D monitoring and other purposes and so on and so forth. But back to the materials. As it turns out, substantial part of what we focus on is international engagement. Let's face it, there are more threats outside the United States than within the United States. And we provide a leadership, we provide support, we provide training, and on equal partnership role. And we actually team up with more than 100 countries under my program, by the way. And one of the programs that I like to focus on a little bit is what we call global material security. We actually focus a lot on securing, properly storing and protecting, and whenever possible, eliminating and reducing and disposing the materials that could be used for weapons, nuclear weapons, whether it's nuclear devices or dispersal devices. So we work with the many international countries to make sure that they know what they need to do. And sometimes we work with them, sometimes we provide assistance, sometimes we provide training. But again, all in all, we have a very robust system of networks throughout the world. And that's actually one of the areas that we actually have almost no difficulty working with all the partners in the world. And the one example that I would actually mention is what we call CHIRP, Cesium Irradiator Replacement Project. For some of you who know, I'm going to bore you for about 30 seconds. Many of the things we worry about include the things like highly enriched uranium, plutonium, and so on and so forth. But again, the commonly used is Cesium-137 for either medical purpose or for well logging, radiography, and those industrial programs. They can be actually used for RDD. So we have decided a long time ago to make sure they're either well protected or we get rid of them by working with the hospitals or whatever the units that might be using these highly radioactive materials. And we have actually begun to replace quite a bit of cesium irradiators in the United States. We're halfway through, actually a little bit more. We hope to convert all of them to X-ray machines. The reason that I mentioned that is international partners are actually asking for our assistance to make sure they actually get to either protect them well or convert them to X-ray machines. And that's the type of thing that we focus on. And many of you might have heard about our Molly-99, which is actually used for, it's actually used to get the technetium-99 out of it for treatment for cancers and whatnot. And there are other types of isotopes that are used for treatments, whether it's throat cancer, lung cancer, and so on and so forth. As it turns out, historically, because of the large cross sections, one could actually make a more Moly-99 that could be used for technetium production out of HU, highly enriched uranium. That's the easiest way to do it. But you know what HU is used for. When you have enough of those material, one could easily make the nuclear weapons with it. So over the last so many decades, we have been working to get HU out of the circulation, especially for civilian nuclear applications. And we have made a tremendous progress, by the way. And the reason that I focus on that a little bit is that today, my office actually sent out the request for proposals, attracting industry partners to come in and to work with us a little bit more. And about a year and a half ago, one of the companies that we started working with started producing Moly-99 within the United States for the first time in about 30 years or so. All this time, we've been relying on overseas supplier to get the Moly-99. And the reason that my office is involved is so that the people, actually more than the just United States, by the way, other countries that use HU would move away from it and use either a low enriched uranium or even LINAC, depending upon the technology readiness level, if you would. So there are a lot of progress happening in that area. So we've been actually getting rid of HU. And for those of you who've been following how much material we have removed over the years, we have taken things out of circulation that you could have made 40, 50,000 nuclear weapons with. The largest amount we get rid of from Russia or from the Soviet Union. But again, we still remove quite a bit of the material. And that's something that we don't talk about openly, by the way. Only after the fact, we kind of file a report to the Congress or other stakeholders. But many of the ongoing efforts, almost all of them, we don't talk about it. We don't want to draw unnecessary attention to how we do what we do. But again, please appreciate the fact that your people, our people at the lab sites and plants, they work very hard to make sure they go where they need to go to retrieve and either protect the materials or get rid of it. And we continue to do that, by the way. Last year alone, we removed quite a bit of both HU and plutonium. And again, we continue to do that. And that's actually one of the things we do. And people focus on the fact that okay, you get rid of the materials. What else are you doing? We're actually proactively engaging with the nuclear industry partners to see if we can actually put the non-proliferation requirements upfront rather than trying to solve the problems after the fact. So we've been engaging more and more to actually build in the nuclear safety, nuclear security, nuclear safeguards requirements upfront in their design and building and operations, so that by the time they start operating, they would not say, "Uh-oh, we missed something." One example that I would share with is one of the offices that I have within the Nonproliferation office is they're actually looking at proliferation resistant core. This is a unique fuel that one would get to use once developed. It actually has a bit of a solution built in, so to speak. So by the time you're done using it, when you take it out, it's easier to get rid of. I mean, that's a cartoon level example that I would give you. But again, we're actually getting more involved at the design phase so that we work with the industry partners and so on. And the one thing that I like to share with you is we have a great partnership with the Office of Nuclear Energy within DOE. They are the ones responsible for finding or leading the nuclear energy peaceful use applications, and we work with them closely. So that's actually one of the things we do. So another thing that I should focus on a little bit is on the screen, you see the set of centrifuges, and you see a lot of materials, and you see weapons in the middle, and so on. My office is responsible for providing the latest and the greatest detection technologies and verification technologies. There are a lot of sensors we developed that we use both on the ground and up in the satellite, by the way. And we work closely with the United States Air Force for them to, whenever they launch a satellite, it's okay for you to assume that there's a sensor package that our labs have developed that they can deploy to look for signatures that are important to our verification work. And part of that is actually there are a lot of universities engaging in on the research, by the way. People think we do a lot of classified work, and we do. But again, we actually support a lot of university programs. In fact, I am very proud of the fact that there are 3 university groups that we fund, and each group actually has about a dozen universities inside. And they work together to work on the cutting edge research at the same time. Focus is on, next generation researchers and so on. And that's actually one of the things I'm very proud of, the fact that while we are addressing today's challenges, we're focusing on next generation people. After all, what good is the fancy tools if you don't have the right people, if you do not have the right people to use and optimize it and make even better use of it and so on. And last thing that I want to talk about, because I really want to leave enough time for questions, is these are my words. We have the policy people in my shop. And for those of you who are familiar with the 123 agreement, Part 810, and export control, and all these things, I have an entire office of experts within the federal system, as well as throughout the lab sites and plants. They get to review the all kinds of things that come across my desk. And they work with other countries. There's something called the nuclear supplier group. Over 36 countries, they get together and share expertise, and they keep the system honest, so that there is no illicit or no bad behavior in terms of sneaking in and getting the technologies or the materials for what we call undeclared activities and so on. And my office also does a lot of policy-related assessments, representing all of DOE, by the way. Again, whatever you might read on newspaper, a country X, Y, and Z, if it touches national security, chances are my office is also involved in providing assessments, because what makes us strong is Nevada National Security Site and other labs like Los Alamos, Livermore, PNNL, Oak Ridge, Idaho, Oregon. I can go through the entire list. What makes us unique is not so much the headquarters. I have a great team of people. But again, nobody in the world has our unique lab, site, and plant system with close to 100,000 people working to avoid the SNT surprises and to make sure we can continue the nuclear deterrence mission, at least as for NNSA portion of it. But again, that's what makes us strong. That is what goes into the assessments, by the way, our expertise. And we advise the Secretary of Energy and the NNSA Council, and goes all the way up. But again, there's a substantial amount of policy-related work. I'm not sure if it would come out as a part of a question, but again, we also do a lot of work domestic within the United States. And many of you should remember that we have a surplus disposition work, plutonium disposition work within my office. And we work closely with the state of South Carolina, great people, and SRS, outstanding team of people. We've been doing this for decades, and they know how to take care of a plutonium material. And there are a lot of legacy waste that need to be gotten rid of. And we work closely with the many people, many labs, to make sure that we do it properly. But again, there's quite a bit of work in that area. But let's see, I've talked about for about half an hour. Why don't I pause at the moment, for the moment, and then see if I can take some questions from people.
Thank you, Dr. Park, for going through all of that with us. Before we answer questions from the chat, I was hoping to have a brief discussion with you about some questions I gathered from our staff members, and some of our board of trustees. And the first one is, how did you go from managing and contributing to research programs at national laboratories as a physicist to the Deputy Administrator for Defense Nuclear Nonproliferation for the NNSA, which is a much more policy development and direction focused role?
I think that people who are working with me today at the headquarters, I think they were stressed out. There was a physicist showing up for a policy position. But as it turns out, that I think the lab experience and the custody experience really helped me quite a bit, because I was actually on the other side of it, developing technology tools or solutions, but to address the policy challenges. So all these years that I was actually leading teams of people and working with them, and I've done a lot of hands-on work myself, were to actually follow the objectives of the policies laid out. And now I'm on the other side. And this is actually quite interesting in that I know what we can do from the technology side, from science side, from engineering side. So I think I'm being a little bit more reasonable, but at the same time, I'm very demanding customer in that I actually push my colleagues to the limit for them to do more in terms of introducing new ideas, new technologies, and so on. But going back to your question, I don't think there's actually any difference between coming up with the technology solutions to support the policy. And right now, my question is reversed in a sense. But again, with the great support and help from my team at headquarters, and I think I'm in a position to mesh the two more effectively. And for the last 15 years or so, since I became a relatively high-level manager, I've been focusing more on the policy-related issues as to how to better enable and support that. So it's not as drastic a change as people might think it is. But again, many of the lab leadership would actually recognize that your turn will come, and please volunteer. Serving the country is always a great thing. I know you have to take a pay cut, but it's worth it. I'm going to challenge all my colleagues to raise your hand when the time comes for you to serve the country. It's always great to serve the country. Back to you.
Thank you, Dr. Park. The next one is, what do you find is the most challenging part of the job? For instance, is it trying to explain a highly technical or scientific topic to representatives of other government agencies? Or is it keeping up with constantly evolving nuclear-related security issues?
So oftentimes I use this somewhat silly analogy, or an example rather, that as a physicist, and I often whenever I go to the White House for National Security Council meetings, which now it happens like 4 or 5 times a week, more so than ever before, is that when you're the only plumber in a town full of carpenters, they pay attention to you. And so I'm actually using it to the maximum to our advantage to make a point. At the same time, it's not so much the difficulty or whatever. My concern is more of, there are so many great things happening, and I only have 24 hours a day. And actually, I'm borrowing my boss, Lisa Gordon-Hagerty's line. I wish I had 48 hours, because I just don't have enough time to project, represent, and provide support to all these wonderful things that are happening. And right now, because of the pandemic, I get the over the phone or VTC briefing from my people. My goodness, it's several times a week. Every briefing, I'm becoming their biggest fan. After every briefing, I want to do more for them. And the concern that I have is that I don't have enough capacity or bandwidth to actually represent what they've been doing so well all these years. So part of my job is to be a cheerleader, by the way. That's what I do. And again, the concern that I have is that there are just not enough hours. As fast as I can process the breadth and just coverage is so wide and deep by the workforce that we have, This is a combination of federal workforce. And by the way, I haven't said anything about Kasia Mendelson. She's my principal deputy. And her team with all the what we call ADAs, Deputy Assistant Secretary equivalent in other departments. Phenomenal job. Again, my concern is more of a not necessarily whether I could explain things to others or not, but it's more of, oh my goodness, I have so many priority ones. And that's actually the difficulty that I have. There are so many great things happening. And I'm not necessarily, I want to clone myself, but I need to clone my leadership team many times over. And that I get to just, encourage them to do their job. I actually have not had much difficulty explaining technical concepts to policy people. In fact, they're much smarter than the many of my colleagues on the technical side, as it turns out, because they actually get the essence of what we're trying to do first and foremost. And so they may not know the formulas or equations, but they don't need to. But again, we get the greatest support from our policy colleagues from State Department, my close friends, Chris Ford and Ellie Kang, and many others, and in other departments as well. Back to you.
Thank you. So in order to achieve the goals of your office, including preventing the development of nuclear weapons and the theft of radiological materials, your team must use some pretty state-of-the-art technology. Are there any interesting tools or instruments that you can talk to us about?
Oh, yeah. Actually, it's people. It's actually relationships with other countries. And I found that to be very surprising as a nuclear physicist, by the way. I spent many years developing the latest and the greatest and the deployable tools and gears and so on and so forth. And obviously, I can talk about that for hours as to what we do in terms of improving detection sensitivity and so on and so forth. But that's what we do every day. There shouldn't be any surprise. In fact, National Security Site is one of the best, if not the best, when it comes to diagnostics. People count on us to do that. But again, for us to actually achieve the higher level objective, we have to work with others, because nuclear nonproliferation cannot be achieved with the US going solo. So as I shared with all of you a little while ago, we work with more than 100 countries. And it's that system, it's that network that makes it strong. It's the relationship. And the same thing happens within the United States government itself. So again, I'm more than happy to give you specifics about the detections of this kind and that kind, and how we actually see, how we actually can listen to the ground moving. We get all that. But that's what we do every day. Improving sensitivity, looking for signatures from distance. We get all that. But again, the solution is in people. That's actually one of the things that I like to focus more on for the remainder of my term, is that when we focus on next generation people, they need to actually experience working with others, not just within the United States, but with other countries, and understanding each other's expectations and how we operate. Sometimes we talk different languages. But again, this seminar, this lecture series does help, because this is actually what we need to do more of. And I'm going to find a way to sponsor more people, to work with others more. But again, the solution is actually in people. And it's not to ignore your question about technologies and so on, but that is what is expected of us. We do better than anybody else in the world. I'm proud of the teams that we have. And the cutting edge research is just phenomenal. If I can add just one word, we cannot slow down, by the way. There are other countries catching up on the science and technology investment. And we need to match the level. We need to exceed that. So I'm glad to see that the country is investing quite a bit on artificial intelligence, the latest, greatest super duper computers and modeling and simulation, and a lot of people. And many people working on the material characterizations and so on and so forth. And again, it's the people, it's the networking, we're in it together, the mentality that would actually make the world safer and better. Back to you.
That's great to hear. Thank you. Now, the next one might be a difficult one to answer, but what keeps you up at night? what are your concerns over the next 5 to 10 years? What do you see being the biggest issues?
So I think I gave a part of the answer a couple of minutes ago, that I just don't have enough bandwidth to project, to represent, and to support all the great things happening. And we actually have a solid support from Congress, by the way. I really need to acknowledge bipartisan support from our Congress. They recognize the importance of doing the nuclear nonproliferation work. And I really need to thank all the sponsors and all the supporters. And to answer your question directly, obviously, we focus on emerging threats, evolving threats, converging threats. And the many people have been talking about cybersecurity already for a number of years. And there are other things that concern us. Like I said a few minutes ago, we need to avoid S&T surprises. That's actually one of the value proposition for having a large DOE lab system, site and plan included, of course, with the thousands and thousands of the world's best people on the technical side and the support and all that. But again, how do we anticipate future threats? So that's actually one of the areas that I'm focusing on with my leadership, working closely with the lab sites and plants. And I'm happy to report to all of you that we're on the verge of starting a new program. This is actually one of the most important initiatives that Administrator Gordon Hagerty has been pushing for. I'm happy to take the challenge head on, and we have a very strong team to push that forward. And under that, we decided to consolidate within NNSA nuclear forensics because it's also material characterization. And one of the challenges we have is typically whenever it comes to nuclear forensics analysis, because of practicality challenges we have, it takes quite a bit of time to analyze the samples. And what we want to do is accelerate analysis. And again, the true leaders like Bill Mayday, who saw the need for all these things from many, many years ago. So there's enough foundation built in our system. So it'll be easy, relatively easy to get things going. But again, it's more of an evolving emerging threats. But I'm going to conclude that portion with the need to focus on people. One of the drivers for actually needing to do all these new initiatives is to attract and retain the next generation researchers and technical people, technical leaders. And there has to be real world challenges that could solve rather than here's a paper problem, go solve it somewhere. That's no way to attract and retain the best problem solvers that we need. But again, our lab sites and plants, especially the national security side, could actually offer the real challenges that people could solve. So it's a combination of all those things. Back to you.
Thank you. And now this is the last question from the staff, and like I said, some of the board of trustees here. And this one actually we've noticed a couple times in the chat. So I think it's it's something that a lot of people have on their mind. How has COVID-19 impacted your office's operations? And how has it impacted the operations at the national laboratories?
Thank you for that. So you're seeing part of my bedroom, by the way. My daughter, who actually works in San Francisco area, she came home. She's actually teleworking as we speak, by the way. And the first basement or first floor, my office, but she took over. But our people are resilient. We have a very creative people who will find ways to get the job done, and that's what we experienced and witnessed. And when we started teleworking, we got worried. Oh my goodness! I mean, we do a lot of international engagement. We have to have a FaceTime. We get a lot of things done in person, in meetings, and so on and so forth. And many of us, starting with me, said, "Oh, we're gonna scale down. Oh, what's gonna happen to us? We cannot slow down nuclear nonproliferation work." It's like when you slow down, there's much more work that you need to do to pick things back up. Guess what happened? We have not missed a bit. All our people, not only at the headquarters, but also at the lab sites and plants, they use the telephones, and they use the computers, and they use the iPhones, iPad, or Android, or whatever. to keep the communication going. In fact, some segments of the workforce are doing better because there's less downtime traveling back and forth, and there's a less overhead associated with the going to work and so and coming home and so on. So overall, I did an assessment, by the way, at the end of March, April, May, June, and so on and so forth. One of the indicators is financial data, not only at headquarters, but throughout the DOE complex for my programs. And for the right reasons, our spending rate is the same as the year before, if not a little higher. And I said, wow, is that people are actually doing more the procurements. By the way, we buy a lot of services to get things moving. I am but for broader NNSA, by the way, I'm very proud of the fact that we planned well. And this is actually the example that I use to communicate with some of my people. So people who do nuclear work, we are used to ALARA concept, as low as reasonably achievable. That's using the distance to stay away from the radiation source, and then put up the engineering control and minimize the time and all that. Guess what? We've been doing this how to protect ourselves and our colleagues and workforce. It happens to be a virus this time, not so much the radioactive sources. But again, especially DOE lab sites and plants, especially the people who do nuclear work, we've been practicing this. It's baked into our DNA already for many, many decades. And by using the well-principled way of working, I think we've been managing, knock on wood, more effectively than the other large organizations. And many of the lab sites and plants on the critical mission side of it, we don't actually bring back our workforce when there's no need. And many of my people actually telework because a substantial part of what they need to could be done from wherever, pretty much, so long as there's a communication and computers and so on and so forth. But the critical mission area workforce actually showed up. They've been delivering. So if you actually look at our milestones and the deliverables and progress, things have been pretty impressive, by the way. And we've been doing it carefully. And I give a lot of credit and kudos to not only the leadership, but also our workforce, for them to take our mission so seriously, and they show up and they carry the mission forward. I just need to say thank you, thank you, and thank you. And I know I have a lot of people in Nevada who show up day in, day out on the critical mission part of it. So, thanks for giving me an opportunity to say thanks to my friends once more. But again, overall, we've been doing well. Obviously, there are parts that we cannot do as well as we did before. And those are the areas we're looking at. But again, overall, we're doing really well. And as we go forward, we're looking at different ways of bringing back that workforce in a more of a coordinated manner, phased approach to further minimize any chances of getting people infection unnecessarily. I've been back at work for about 10 weeks now, by the way. And I enjoy easy commute, by the way, with less traffic and so on. But overall, I think we know what has to be done, and the people come in when they need to come in for classified meetings or research or whatnot. But overall, I think we've been doing really well. And but again, this is one of those that I think the nuclear workers are more trained to survive and to do better. It's just that we've been operating in this kind of mode for many decades in terms of taking care of ourselves and our friends and our colleagues and our environment and so on. But again, there are other challenges in terms of people having to take care of their friends, their family members, and so on. And so there are some real challenges that we need to overcome, that I need to recognize. And with the many schools doing online learning, many young families with little kids, it's hard to do the daytime work and then take care of kids. We recognize it. So we're trying to be as flexible as possible. I have grown kids myself, so I'm not really worried about that much. But again, we are actually exercising our the authority to make sure we take care of our people. We need to get out of this situation that we're in, but while we're in it, I think we're doing a really great job because we have very many teams at different locations looking at ways to better protect the workforce and so on. Back to you.
Thank you. Okay, we're going to go into the chat and the Q&A section and pick out some questions for you, Dr. Park. One kind of reflecting a lot of different questions that we've been seeing in the chat is, what are your thoughts on how the U.S. relationship will evolve with Russia in the area of non-proliferation? And I think I've been seeing a lot of questions about China as well in that regard. Just how is that relationship going to evolve, and what are some of your thoughts on that?
So that's actually a very important question, by the way. I think the all in all higher level objectives are agreed upon. It's a matter of how we do it, and that therein lies potential the opportunities for partnership, compromise, and the sharing the lessons learned and so on and so forth. And it's one of those we cannot give up. That's not an option, by the way. Non-proliferation is not something that we could give up. Anybody could give up. It's a must. And so once you recognize it, I'm hopeful that we can find ways to work with the not only our allies, but some of the nations that we may not see eye to eye on some of the issues. But again, I think another way to overcome the challenge that people are asking the question is by engaging with the international community, like IAEA. By the way, we work closely with IAEA, like all other countries do. And it's actually a great idea for us to work with the recognized authority in the nuclear field, International Atomic Energy Agency. And therein lies that opportunity for minimizing misunderstandings and confusions and so on and so forth. And we actually have taken a leadership role in many of the things, working directly with IAEA, sponsoring many of the workshops, training opportunities, and so on and so forth. And whenever I visit with or meet with my counterparts from China, Russia, Japan, South Korea, UK, France, any country, I challenge them to step up and do more. There are many countries who cannot afford to do all these things to improve nuclear security safeguards and safety and all these things. I challenge them, do more. Let's do more. Either you do it on your own, let's do it together. So I think having an important international body such as IAEA, and we've been working with the European countries quite a bit. And last year I've been to Japan and South Korea. Great partners, by the way. They're outstanding. They're they've done much more than anyone could have hoped for in the last 5, 10, 15 years, and the improvements are just phenomenal. And so I think there is the looking for mutual ground, I think is the way to go to get over difficult situations. But again, I'm a firm believer that everybody agrees on the importance of non-proliferation. After all, they signed up for NPT, Non-Proliferation Treaty, and many of these countries are also nuclear supply group countries. And so we actually share the same value in making sure that globally there's no nuclear threat, or we need to find a way to reduce it to the extent that we possibly could. So I haven't given up. I don't think I will ever. But again, our people are very creative in looking for ways to partner with them through the means available. And again, oftentimes we work directly with IAEA to do outreach to many other countries. So that actually has been working really well. So again, narrowly focused on proliferation areas, I still have hope that we can find ways to get things moving. Again, if they want to go on their own to work with other countries to improve their qualities, go for it. I challenge them all every time. And that's what we have been doing. And our greatest partners are obviously the United Kingdom, Canada, and many European countries, Japan and South Korea. They're outstanding partners, and there are many more, by the way. But again, our challenge, I've been to China several times. I challenge my counterparts to do more. And in some areas, they have stepped up, which is a good sign. Back to you.
Thank you. This next question is, you've been in the industry for a long time. Now, what are some of the biggest changes you've seen along those years? And what are some of your proudest moments of using these experiences in your career to deal with the current challenges that the NNSA are facing?
So I did not know how critical and important and useful DOE labs, the site experience was until I got out. By the way, especially when it comes to anything nuclear, there's nobody better than our system that we have. After all, we literally came up with the many things that the world is using today through our lab system. Oregon, Chicago, and Oak Ridge, Los Alamos. I mean, there are a lot of things that our country developed using our universities and the lab systems. But again, it actually gave me a unique perspective of, wow, whatever I actually did all these years, starting with the basic nuclear physics experiments with the John Ullman and all those wonderful physicists that I actually learned a lot in those late 80s and early 90s when I was in basic physics. But again, I think I'm actually happy to validate that what's actually happening, what has been happening in our complex is actually meaningful and important, relevant, and impactful in many different ways. And this is more of a how DOE is nurturing the workforce. It's paying off real time, and many of those people are in other departments and agencies. And many of those people actually work in international organizations. So great experience overall. I'm not sure if I answered the question, but again, it's one of those that I was able to actually appreciate more after I got out of the lab system. Back to you.
Okay, thank you. And look up some more questions here. We are getting a lot of questions about just the future of some of the treaties that are in question, and what are the challenges you're going to be facing with more verification treaties, and the things that we get renewed, and obviously with talking about China and Russia. What is your view on the future of these treaties? Are some going to be renewed? Are there going to be new ones introduced? We'd like to get your opinion.
So I appreciate that. So the way I look at treaties, it's a promise. It's if it is bilateral, two countries agreeing, or many more countries agreeing with each other that they would follow whatever terms that they agreed to follow. And so long as the promises are kept, treaties are great, and as evidenced by the fact that we got out of one not too long ago because promise was not kept. So we focus actually quite a bit on the detection technologies, monitoring capabilities, and verification technologies, and so on and so forth. But again, the policy has to be supported by the technology solutions so we can validate. And I'm hopeful that that we can enter into the promises, knowing that both sides could actually validate the claims or the agreed upon terms. When one does not agree to the terms, it's difficult to hold on to the treaties, which is actually a promise. So I think we took a leadership in the form of, hey, let's make sure that everybody keeps its words going forward. And but again, I'm hopeful that all the things that are ongoing could result in something more positive for all the countries involved. Let's see what happens, but I'm hopeful that the countries, as they get to renew or they get to enter into new treaties, they just need to remember these are promises between the countries, and they need to be kept. So, but again, I don't look at it as a necessarily negative thing. When promise is broke, now you have to do what you have to do. But again, I don't want to get into anything specific, but those are my general observations as a physicist. Again, the verification and monitoring technologies that we develop would support more robust policy making that could go into these treaty conversations and agreements or whatever. Back to you.
That's interesting. Thank you. Here's another question. Dr. Park, I'm interested in how NNSA's policy work intersects with the policy team that now reports to the secretary. Is there a collaboration, or does the policy office just deal with the energy side of the department? Full disclosure on this question, this person was in the policy office to the previous administration. It always struck them that the DOE didn't integrate the full mission of the department in the office at the policy level. And they just want to get your opinion on that.
Oh, thank you very much for that. And so obviously NNSA focuses on more of a national security mission, nuclear deterrence. And the secretary has a full access to everything that we do, by the way. And oftentimes, whenever there's a national security briefing, it's actually mostly my team, my experts who go into the secretary's room, and we provide the background and so on and so forth. It's not so much that there is the separation, but again, there's a bit of different ways of handling what we call energy sector side and what we call national security side. There are many teams within DOE. DOE is actually a very complex and very large organization that does from open science, basic science, Office of Science, to ERE, to ARPA-E, to Office of Nuclear Energy, to coal, I mean, there are a lot of things. There are many offices, and I'm not sure if I would agree with the characterization about not being integrated. I think the way we operate is we all bring relevant information, and then the important thing is, although my title is Deputy Administrator, in reality, I'm Assistant Secretary. And I work with my counterparts throughout the department, and then we compare notes and we provide that information to undersecretaries, and then they get to actually decide how to roll it up to the secretary's office and so on and so forth. I don't necessarily see that as a this or that. It's more of a slightly different way to focus on the mission space that is very large and complex within Energy Department. And again, I focus on more or less exclusively on national security, and much of data that I have to look at and analyze and assess are of that nature, rather than commercial segment or industry side that may have to talk about liquid, the LNG or other types of energy sources and so on and so forth. But again, I think I don't mind that the description or characterization, because it shows that DOE is a very complex organization that does many different things. In fact, it has been quoted several times. Previous secretary, former Secretary Perry, actually said DOE stands for Department of Everything, by the way. In fact, you might be surprised how many different things we do at the department. But again, in terms of integration, could it be done better? Sure. Is it being done effectively? I think so. Again, we always look for ways to improve, but again, NSA focuses primarily on the nuclear deterrence, nuclear security, national security side of it. But teaming and the partnering with other parts of DOE, I think, is being done pretty well. Back to you.
Thank you. This next question, we'll answer or pick out a couple more for you. I know it's very late there, so thank you for pulling an all-nighter with us tonight. The next question would be, if you could choose the next technical breakthrough that would maximize the effectiveness of your programs, what would it be?
So that's actually interesting. And so people like me worry about the life cycle aspect of nuclear material and how it's produced, how it is used, and how they are disposed. And so an example of a Procore that I mentioned, the new fuel that actually has all the safety features built in, security features built in. It might be actually interesting to probe that a little bit more and to see if we can actually make a breakthrough. So people like me would not have to say, no, not just yet. You need to do more assessment. Let us work on this a little bit more. But I like to say yes. And in fact, that's what we do. We work with others to find a way to say yes. In fact, I just borrowed Administrator Gordon Hagerty's favorite phrase, by the way. Let's find a way to say yes. And so some of the technologies, again, I can't give you a dozen more, but when it comes to nuclear nonproliferation, when we find this unique fuel, the way we can actually make and use and get rid of, world might be safer, first of all, much safer, but at the same time, people would like me more. And there's nothing wrong with that, by the way. I like people to say, here's Brent Park, and welcome me more. But again, the part of my job is to say, well, let's think about it more. Have you addressed these issues and so on? And that's actually a lot of what I do with my people. But again, in terms of technology breakthrough, I'm a big fan of small modular reactors, micro reactors, and so on and so forth. But again, if you bundle that up with fuel, and that could actually withstand abuse, challenges, or theft or whatever, I mean, that would be just awesome. And so I'm hopeful that we actually have a robust program going. That's actually one of the things we're pushing forward. And but again, it's not so much one the small tool that will do things. It's more of a fundamental change to how we operate our nuclear programs. And as there are more countries interested in nuclear powers, and it'd be really wonderful to actually say, remember, it is the United States who actually share the nuclear technologies. I mean, all of you should remember 1953 Eisenhower speech at UN General Assembly. Atoms for peaceful use. And I think it is up to the United States to show the leadership, working with other countries, other the organizations, to come up with a unique fuel that would substantially minimize the threats and concerns and so on and so forth. That'd be my dream solution to substantially reduce the nuclear threats in the world. Back to you.
Thank you, sir. The last question is, I find this an interesting one. How does everyone get the info they need for getting these materials? So we're obviously talking about stopping people from getting their hands on it. How does everyone get the info for what they need? And how do people who give you your info get info to get this stuff? So basically saying, so how you get your information, who gets you that information, and how do they figure out how people are getting their hands on it? So I think back to the tech side of it.
Right. So first of all, for those of you interested in how things work, please join the government system or the lab sites and plants. We have plenty of jobs. Obviously, I cannot share with you all the routes or the sources that we use because we don't have enough time today. But so what we normally do is we work with the what we call NRC, Nuclear Regulatory Commission, within the states, within the United States. There are other regulators in overseas location that they keep track of where the material should be. And when they find discrepancies, then that's actually one way for us to know, oops, we actually had whatever 100 units, and then one day you walk in and then there are only 99. And so those are the things that we would look for. And much of the information that we get are voluntary. And much of the information that we get are more of what I call through network that we have. And especially when it comes to large quantity material, these are actually well known. One good example that I did not get to talk about too much is we've been converting a very large research reactors over the last 40 plus years, by the way. And these research reactors use a highly enriched uranium, some small quantity, some very large quantity. So there are many, many things that we know that they're there, we need to get rid of. We work with foreign countries. We work with IAEA and other countries and organizations and so on and so forth. So a substantial part of what we actually get rid of are coordinated. And that's probably in the upwards of 95% or close to 99%. One of the things I talked about at the very beginning of the talk is materials, and the security and how to protect or whenever possible get rid of it. And we actually focus quite a bit on the nuclear smuggling. That's where working with other countries really pay off, by the way. We actually deploy portals, radiation sensors, and so on and so forth. And there are many, many countries who can afford their own. They're fine. They get their own system. They just buy theirs and work with us. There are some countries who cannot pay, and we work with those countries, and we try to equip them, train them. But again, it's through network of detections, not just in a single location, but throughout the region, like European countries, former Soviet Union areas, and so on. We get to actually do mobile detection at the fixed locations with the radiation portals and so on and so forth. But again, it's a combination of all those things that actually give us a chance to kind of find out where the materials are and when they're not where they should be. And that we go activate the system. And I probably have not mentioned it, but one of the international organizations we work with is Interpol. And many people actually don't know that. Interpol, and we work closely with each other, especially with the many partner countries. So they're in on trafficking, illicit material shipment, and so on and so forth. And so it's a various combination of sources that we get the information from. It's not just one source, but again, oftentimes it's their oversight body that actually keeps track of it. We encourage them to do regular inspections and so on. And of course, there are other means of collecting information. But again, overall, it's a very well coordinated effort for us to find out where the material should be. And then we work with the sponsoring countries, IAEA and other institutions to better protect or get rid of it. Back to you.
Well, thank you, Dr. Park, for it was an honor and a pleasure to have you here, and for taking everybody's questions and sharing your expertise with us tonight. For those who are attending this, if you're interested, next week, we will actually be having a survivor speaking, a survivor of the 1945 atomic bombing of Hiroshima, sharing their experiences next Thursday, August 6th at 6 p.m. Pacific and 9 p.m. Eastern. And it's through our partnership with the Hiroshima Peace Memorial Museum. And so due to the 75th anniversary of the bombings of Japan, we are going to be having that talk free through Zoom. Please check out our website to learn more information about it. Also, the museum is open. We're open Thursday, Friday, Saturday, and Sunday from 10 a.m. to 3 p.m. And we have a brand new Trinity exhibit talking about the 75th anniversary of the Manhattan Project and all of the people and the facilities that were involved in making it a success. So we look forward to having you along for this virtual ride. And I want to say, if you enjoyed tonight's talk and if you enjoyed our talk a couple weeks ago and are interested in the upcoming ones, please consider helping to support the museum. Consider donating. It's not required, of course, but we appreciate any support during these trying times. So thank you all so much, Dr. Park. It was a wonderful experience having you tonight. Everybody have a great evening. Thank you, those of you who stayed up very late. Thank you again, and have a wonderful evening.